All right, so we'll look at question 6. Look at question 6, and I will start from here. So they're telling us that the curvature of a curve R T is given by this here, and they're saying show that the plane y equal to f of x, the curve is equal to whatever this is. So we must show that. So how we do this, we will say we have y equal to uh, f of x, then we will say r, let r. So here they're telling us that r prime of t cross product of r double prime of t over this is equal to the curvature. So we'll write our equation in terms of r. So we say r of x. So if we had r of x, we had a vector r of x such that this vector is defined by an input of x and what? F of x, like this. So now, when we have this, we can differentiate this and we get r prime of x is going to be, differentiate x, you just get 1. Differentiate f of x, you get f prime of x. Then you get r double prime of x. So r double prime of x is going to be, differentiate 1, you get 0. Differentiate f prime, you get f double prime of x, like this. So after getting this, what we do next, we must check here on top. As you can see inside, you have r prime of t cross. So they're finding the cross product with r double prime of t. So we'll do the same. We'll say r prime of x cross. So we find the cross product with r double prime of x. So this is going to be equal to, if it's going to be a cross product, I'm going to put this in a matrix like this. Then I'll say I, J, and K as my unit vectors. Then I'll put in these vectors the way they're following each other. So I'll put in R first, which is 1. It's 1 F prime of X. Then here I don't have any value, so I just put 0. Then the other one is 0 F double prime of X, then 0 there. So to find this cross product, so you choose here, we choose the last row, as you can see, because it has zeros here, so it will be easy to cancel out. So when I pick K there, this here, will cancel out, then I remain with this minor here. So with this minor, I have to find the determinant of this minor that remains there. So I have my K, so this is going to be equal to K. Then I find the determinant of this here. So the determinant of 1, 0, that's f prime of x and f double prime of x. Okay, like this. So now, what do I get next? So from there, can say when that multiplies out, you get that that will just be k. So 1 multiplied by f prime of x, you get 1. But this side, you have 0 multiplied by f prime, that gives you 0. So you just remain with f double prime of x. So this is our r cross, this is our r prime of x cross r double prime of x. This here, k double prime of k f prime, f double prime of x. So this is what you get. Now, from here, what you do next, you say, you put this, because here on top, they're showing us that they're finding the magnitude of r prime multiplied by r double prime. So even as we put the magnitude of r prime of x like this, cross r double prime of x. So remember that this is just here what we found, k can be written as a vector to be 0, of course, comma 0, comma f double prime of x, like this. This is how it's going to be written, because we only have a value at k here, which is this part. Then here at j and I, there's nothing. So we write it like this. Then when we plug in this here, we just get, this is modulus of f double prime of what? Of x, like this. So this is what we get when we plug in that. Now, we have to get what is down there. So what is down, they're telling us, if you can see here, there's r at r prime of t. So even as we get r prime of, so I'm saying r prime of x, like this, modulus of r prime of x. So we already have r prime of x. We found that, and we found that it was, so it was 1, said 1 comma f prime of what, of x, like this. So now plugging it into this point here, we're saying, as you can see, what this means is this to my modulus here just means you're finding the magnitude of this. And when you have a vector, so when you have a vector, right, yes, erase this part. So when you have a vector, so let's say we have our vector, which is a, comma b, comma c, like this, then you're told to find the magnitude of this. So the magnitude is just the same as this is in what is in the modulus, like that. It can be double, single, just, yeah, like that. And this is given by, this is going to be where you square uh, each coordinate that you have there. So even as here, when we put it like this, we'll just be what? Squaring each term of f of this r prime of x, of which we only have one, and the f prime of x. So 1 squared just gives us 1 plus we square f prime of x. So that is going to be f prime of x what? Squared, like this. So this is what you get. Now, from there, we can, from what we have here on top, they're telling us that uh, kt is equal to this. So we have what's on top and what is down as well we have. So we can what, just replace that. So we'll get that this is going to be, so we'll get that our uh, k kt is going to be equal to, so here r prime of x cross r double prime of x is just the modulus of f prime of x, as we found. Then this is divided by, so we're dividing by what? This here. But I know I can rewrite this in the form 1 plus f prime of what? Of x, like this, squared, of course, then 3 over 2. So 3, okay, not the 3, just 1 over 2, sorry. So here, the power, because it's a square root, so it's going to be to the power at half, like this. So I can put that down, which is going to be, and already it's in the modulus, but it's raised to the power at 3 there. So let's do that. So we'll get, this will be 1 plus f prime of x. So I have squared there, then I have 1 over 2. Okay, then outside here to the power 3, because as you can see, there we have it to the power 3. So it's like this here, which we found this part to the power at 3 now. So this is what we've done. We've just rewritten what's inside and raised it to power 3. And of course, this 3 can multiply this power, and you have k of t equal to modulus f prime of x closed divided by, so that would be 1 plus f prime of x squared, then 3 over what? 2. So now this is the end of what? The proof. So you can write down there wherever you end the proof, just say hence what? Hence shown. So you're done. You've showed that this is equal to that. So here there was a mistake in the question. They needed to be squared here. Yeah, they needed to be squared. I think the correction was made during the exam. But yeah, to come out like this, so this is your answer, and this is how you prove. Okay, so next we have this question here, and the question says, given that r is equal to that there, which we have, and if it's equal to that, they're saying find the curvature of the curve at t is equal to 1. So what do we do here? So curvature, there's that formula which we've seen, but there's this other formula where we say curvature is equal to the modulus of t prime over what? R over modulus of R prime, like that. So t prime is just the what? The tangent vector. And the tangent vector, okay, so t prime is when we differentiate the what? The tangent vector. So meaning for us to get t prime, we have to have t. So t is given by, so t, which is the tangent vector, is given by rt, like this, r of t over what? Modulus of rt, like that. So this is how it's given. So meaning for us to find the curvature, we need to get what's on top here. But first to get what's on top, we need to find these things here and then just differentiate this one. We already have, of course, the one which is what on the bottom because it's also down here. So how do we do that? So we'll get, this is our r right here. So meaning we have to differentiate that what? That r. So we say r prime of t is going to be equal to, differentiate this first part. In differentiate 2, you just get what? 2t, like that. Mean 2 squared, you just get to t. Then differentiate 2 sine t. So when we differentiate sine, we get cos. So this will be 2 cos t. Then you have the other part to be 2 what? So that will be negative because here we're differentiating cos. So it will be negative sine what? Sine t, like that. So we've differentiated this, but we have to find the magnitude of this. As you can see here down, there's what? It's in the magnitude. So magnitude of RT, like this, is easy. We just have to what? Square each term. We just have to square each term. So we have that. So we have to find T squared plus 2 cos T squared plus negative sine T squared. Okay, and that is going to be equal to, so what do you get when you do that? So that will be 4 squared, then plus 4 cos squared t plus 4 sine squared t. So you get that there. Then from there, you can factor out 4 since they all have 4. So I can factor out 4, 4, then I'll have t squared plus cos squared t plus sine squared t. Okay, so here since they are multiplying, meaning I can find the root of 4, then I can find the root of whatever remains there, which is t squared plus cos squared t plus sine squared t. So here I get 2. This here is an identity. Sine squared plus cos squared gives me 1. So I just have t squared plus 1. Now they're telling me at a point where t is equal to what? To 1. So I can replace my 1 there. So it will be 2. 1 squared is just 1 plus 2. So this just gives me 2 root of 2. So I have found the magnitude of r what? R prime of t. So I need to keep that. So let me just write it here. So that is going to be, okay, so that's going to be modulus of t prime of t, like this. It's going to be equal to 2 root of 2. So I get that there. So what next do I have to do? So I found this as my r what? R prime. So this is my r prime. Then my formula to get t, to get the tangent vector, we said it has to be r prime over the modulus of r prime. So I have the modulus and I have this vector, which is this one. So I can find t. So t is going to be, let me grab this part. Okay, so my T is going to be, so I have this here, so which is my what? My R prime, then I'm dividing it. So this is just going to be divided by, okay, let me do this. So this is going to be divided by, saying this divided by 2 root 2. So when we get that, here these all have 2's, so these can divide into what? Into each term, which means the 2 what will go, and I'll remain with T over cos T negative sine T, like this, over what? Root 2. Of course, I can divide the root 2 into each one of them, and I'll get, this just gives me T over what? Root 2, then cos T over root 2, then I have sine T over root 2, like this. So this is my T. So now from here, you can observe that we can get our T prime. So we can get our T prime from there. So they're saying, how do we get our T prime? We just differentiate this. So T prime is going to be, here we have this T. When we differentiate T, you just get 1 multiplied by the root of 1 by 1 over root 2. So they are just remain with 1 over root 2. Then for cos, what do I remain with? So when I differentiate cos, I get negative, sine T, of course, over root 2. Then when I differentiate, so it has to be negative, yeah, negative sine T. I'll get negative cos T, like that, over root 2. So this is my T prime. So from T prime, I can get this modulus of what? Of T prime, which is just the magnitude of that. So that will be the root, then I square each term, 1 over root 2 squared plus negative sine T over root 2 squared plus, so this is negative cos T over root 2, like that, squared. So now what do I get from here? I'll get that this is going to be, so the first one gives me 1 over, so root 2 by root 2 just gives me 2. Then I'll have this squared, just going to give me, this will be plus sine squared T over 2. Then I'll have plus cos squared T over 2. So I get this. And from here, I can easily factor out my 1 over 2. You can see. So I'll get 1 over 2 root. Then I'll have what? I'll have, so 1 over T. I'll have 1 plus, there I'll get sine squared T, then plus cos squared T. So this part here, of course, this part sine and cos, this here I can add, because this is an identity of 1. So I'll just have 1 of 2, then 1 plus 1. Then this is just going to be equal to, so this will be 2, and 2 divided by 2, I get 1. So this will be 1, and this will be equal to 1. So my ROC is just 1. So that's what I get. So from there, I have what I need. The top part and the down part, I have all of them. So I can compute my curvature. So this here, let me erase. Okay, let me erase this. So I found 1 there. So that means my T, like this, this is equal to 1. So if it's equal to 1, then my curvature now I can compute. This is going to be what I have on top here, which is t prime, and the magnitude of t prime, which we found to be 1, and then divided by this part here, which we found to be 2 root 2. So this is my curvature. Yeah, so I've computed my curvature. That's my curvature there. Okay. Don't know if there are any questions here.
Uh, there are no questions. It's just a lot, so I'll just have to go through on my own.
Okay. So then the next one is this one here. They are telling us to evaluate this. So in order to evaluate this, we'll use total differentiation of partial versus orders. So now, in order to do this, so they're saying estimate the value of what we have here. So when we have a function that is that is given in terms of versus in terms of two variables. So let's say you have a function f of x and it's in terms of two variables, that's x comma y, meaning you have to have an x and a y input. So they've given us this one. So meaning when we have it like this, it would mean our function has to look like x squared plus y squared like this. Okay, so we have it in this form. Then when we have this, for us to compute whatever we want to compute like that, we have to put into play, first of all, the us using partial differentiation, and also how to just work around this. So now, in general, if you have these points, okay, so if you have those points, so let's say we are calling those points to be, we have those points 3. So where 1 is for x and the other one is for y. So 0.4 like this and 9.5, we have them like that. So now, in order for us to compute this, we have to find f x comma y. Then we add with this is the partial of f of versus f comma y with respect to x in this case. So you be differentiating this like that, then dx plus the one with what? Y. Now we do it with respect to y. Okay, then dy. Then you would have found the what? The approximation of this. So now let us get what we need. So we have this first part here. How do we get this one? So now this one, the first part, it's given by, okay, so the first part, uh, we get it by finding the change which we have here. So you have to look for values that are closer to these numbers which you were given. So in the first one, we have 3, 0, 4. So you have to look for a whole number that is close to this one. And the closest whole number to this one is what is 3. When we round off here, we will get what? 3. Then we have 3.95. The closest whole number when you round off is what? Is 4. So meaning that there is a change from your numbers from uh, you're having a change from, you are going from 3 to this one, and from 4 to what? To that one. So that's the change which you're having. So meaning when we are subtracting, you subtract this one minus that one to find your change in this case, it's your change in x, and you have to find your change in y. So your change in x is just equal to dx, and your change in y is just equal to dy. So you have to what? Do that. So to find that, let us first find the same change in x and the same change in what? In dy. So our change in x is just going to be, so you get the last point which it changed to, we are saying it's 3.04. then minus this here, which is 3, and you get that this is equal to 0.04. Then you have change in y, which is going to be here, that's 3.95 minus 4. And that will give you 0.05, that negative 0.05. So you found the changes first of all. Then the next thing now that you do, so let me write these changes here on top. I write my change in x is 0.04. Then the change in y is just negative 0.05. So those are my changes. Now I have to get this part, then I evaluate. I plug in my x and y. So our x and y, which we're considering, are these the whole numbers, the 3 and the 4. So you plug in 3, so it will be 3 for x, that's 3 squared, plus 4 for y, which is 4y. And this is going to be 9 plus 4 plus 16, and this gives you root of 25, which is just equal to 5. So meaning I can write here that my f of x comma y, already evaluated at the points, is going to give me what? 5. So now what I do next is I have to find this part here. So how do I get that part? So I will get this same function which we have here. So I can write that function. I can write it as so I can write it, that can be x plus y squared to the power 1 over what? 2, like that. So I can write it like this. Then I must find the partial with respect to what? To x, like this. So meaning I will be differentiating x, then I will be considering what? The y to just be a constant. So when I differentiate here, by chain rule, of course, differentiate what's outside, I'll get 1 over 2, then keep what's inside constant, like that. Then I subtract minus 1 in the power, I'll get negative 1 over 2 here. Then I differentiate what's inside, so what's inside, I'll get 2x. Then here the y part, I consider it as a constant, so it will give me 0. So now, which means these 2 can divide into this other 2, then I'll remain with the x. So that is going to give me x on top. Then I can write this as a negative, so I can write it in the bottom to have a positive power, and of course it's half, meaning it will be root of x squared plus y squared. So this is what I get for my y, this part here, when I do it. When I do it with respect to y, I'll just get the same thing, but I'll have y over root of x squared plus y squared. So now at this point, I must put in my x and my y values. I must evaluate this. So what I get when I evaluate, so I must put my x there on top, which is by saying my x is what is 3 and my y is 4. X is 3 and y is what is 4. So to be 3 divided by, so x squared here down, we already found this here down, which was, it was 5. So you know it will be 5. Then this same one again, you put in your y, and what's down, you know it's what? It's 5. So we found this part here. We found that to be 3 over 5, and this other part to be 4 over 5. Then this here, the change in what's this, we've already found them as on top there. So now from here, we can now just plug in our values into this equation. So we'll do that. Okay, let me plug in. Let me erase this here. So when I plug in the first part, we got what? 5. Then this part here, we got 3 over what? 5. Then this is multiplying with the change in what? In x, which is 0.04. Then plus, you have 4 over 5. Then multiplying negative 0.05. So we'll get that when we multiply. And evaluating this, Okay, when we evaluate this, we get here at the first, this will be plus 5. 5, then I can multiply 3 over 5 multiplied by 0.05, and I'll get 0.024. Then I can multiply the other one, 4 over 5, then multiplied by negative 0.05. Then I get here, I'll just get negative 0.04. Then I can subtract those, so I get 0. Okay, so can subtract that, I'll get 0.02, 0.024, minus 0.04, and that gives me, this will be 5 minus 0.016, and my final answer is then going to be, this is going to be 4.984. So this is the approximation that I get, 4.984. And if I was to get my calculator and plug in these values and evaluate that, so when I put in 3.04 squared plus 3.95 squared, like that, I'll get an approximation of the CM, which would be 4. So it gives me 4.984385, and of course it's this close to this approximation. So this is how you estimate that value there. Next, we have this question, which is the last and final question for this class. So how you show that the limit does not exist is, so when this limit approaches different values. So if I plug in, so I'll show you how to plug in, but if the limit maybe gives you different values, gives you 1/4, then it gives you 0. When it just differs the limit, the value which it is approaching, then this is going to be that the limit does not exist. So now, in order to show, what you do is you have to, so you first of all you want to deal with only one variable. So you say maybe let x equal to what? Or let y equal to what? To x, like this. So you can show this by letting these points, let's say y equal to, can say y equal to 0, x equal to 0, can say y equal to x, or x equal to y, or y equal to what? X squared, or it can be y equal to mx, like this. It can be a linear basis function. So you can let it equal to any of these. So mostly just test these squared, this, and the ones for zeros. Then you see if it does, if it gives you something, if it continues to go to the same limit, then the limit exists. But if it changes, then the limit does not exist. So we start at y equal to x. So say the limit of x comma y as it approaches 0, 0 here is going to be, so why there's y, we replace what? X. So we replace there with x, and you have squared, then that will be x squared plus that will be 4, so that be x to the power 4. And this is going to give me that the limit of x comma y as I approach 0, 0 is going to be, so that will be x cubed on top, then I'll have x squared plus x to the power 4. I can factor out there down, factor out x squared, then I'll have 1 plus x squared. Here it divides, so I'll have the limit as x and y approach 0, 0 to just be, so there I'll have x on top, then I'll have 1 plus x squared. So here when I plug in my x, I'll have 0 here, I'll have 0 there, and this just gives me what? 0 over 1. And if this gives me 0 over 1, then I'll have what? The limit is 0. So let me check another one. Let me say I check, let x equal to y. Able to see it now? Hello? Are you able to see where I'm writing from?
Yes, I can.
Okay. So we are saying let x equal to what? To y squared. So our limit x comma y approaches 0 comma 0. I'll have where there's x, I'll replace y squared. So y squared multiplied by y squared, then divided by, down there to be y squared, then y squared plus y to the power 4. So the limit x comma y, okay. Here on top I'll get y to the power 4. Then I also get there y to the power 4 plus y to the power 4. So this is going to be the limit x comma y approaches 0 comma 0. Then I'll just get, I can factor out the y squared down there. So I have y over that, then that will be, oh, in fact, I can add this down there. I can add, I'll get 2y to the power 4. So the these y's squared divide, then I just have the limit as x comma y approaches 0 comma 0, and I'll just have 1 over 2. Of course, when I plug in here my 0 comma 0, this is going to give me what? Half. So at first we got that the limit was 0, and now we're getting that the limit is what? Is half. So because they are giving us different limits, this here will conclude that the limit does not exist. So the limit does not exist. So if it limit doesn't exist. So if it kept on giving us 0, let's say it kept on giving us 0, 0, 0, 0, then we would know that the limit what exists. But now it has given us a different value, meaning the limit here does not exist. Okay, so this is how we go about this question, and this marks the end of this class. I don't know if there are any questions.
So you said the value that you test is when x is equal to y, x is equal to y squared, then which other one?
So you can test x equal to 0, you can test y equal to 0, you can test this x equal to y squared, or you can test y equal to x like this, or x equal to y, whichever one. Yeah, you can test these main ones, and also you can use a linear analysis, a linear function where I just say maybe y is equal to some value mx like this, mx plus plus maybe plus 1. Yeah, it can be like this. So you can test those, then you check. But mostly when you check this 0, 0, 1, this one, and the one we're from doing, you see whether it's going to approach the same limit or not.
Okay, thank you.
Sure. So this is the end of our class. If there are no other questions, we conclude here. I thank you for attending.